We begin with the following situation. We have an 80 centimeter table, 80 centimeter high table. We have an object going off the edge of the table at 70 centimeters per second in the horizontal direction. And we're going to find the displacement delta x corresponding to this situation, the displacement delta x along the level floor. Since the velocity in the x direction, or the velocity is horizontal, then there is zero velocity in the y direction, of course. Now, you should pause the playback and attempt to solve this problem before we move on. The next thing we're going to do is we're going to find the delta t. That's the time required to fall the 80 centimeters from here to here during the uniform acceleration phase from the edge of the ramp or table to the floor. Now, the fall is going to be under the influence of gravity. The y motion is going to start at velocity 0. The displacement is going to be 80 centimeters, assuming the downward direction is positive, and the y acceleration will then be 980 centimeters per second squared. Using this information, we very quickly obtain delta t equals 0.4 seconds. If you're not sure how that came about, then you need to review previous lectures. So we see that the time of fall is going to be 0.4 seconds, and we've seen that that time of fall is independent of how far the object goes in the horizontal direction. We can find that again by flicking a washer off the edge of a table. The washer will follow this kind of a path, and at the same instant we drop another washer. We can hear the washers hit the floor at the same instant, or very nearly the same instant if we can manage to drop the two washers. To drop the one washer is at the same instant that we flick the other, or at nearly the same instant. Now, we found our delta t. We have no acceleration in the x direction because there's no force acting this way or this way, except a negligible amount of air resistance and a few other even more negligible forces. So that the x velocity is going to be constant since the acceleration is 0, and since it starts at 70 centimeters per second, it's going to remain at 70 centimeters per second. As a result, well, our delta x is just going to be our x velocity times delta t, and we multiply this x velocity times the 0.4 second delta t that we just found, and we obtain 28 centimeters for the x displacement.